So we can find the area of non-perfect squares by breaking up the non-perfect squares into right triangles and square areas. So in this case here, this is a non-perfect square. So to find the area of this non-perfect square, I can use these lines. So I start at the vertices and I can draw straight down until I hit this line here, where I draw straight across. Okay, my pointer here is this line here. I can go from the vertex straight down to where this vertex is, go straight across. Okay, we can draw these right triangles, and then we can calculate the areas of these right triangles. So when I look at the right triangle here, it's going to be length times width, or base times height, divided by 2. So my height in this case is going to be 4. If I count across 1, 2, 3, 4, 5, 6, 7, 8, 9, it looks like that it's 9 across. So the area, I'm just going to maybe label this slightly differently. So that's going to be 9, okay, from here to here. So the area of this right triangle is going to be 9 times 4 divided by 2, or 18 units squared. And if we take a look at the symmetry of this diagram, these are all the same right triangles. So this is going to be 18 units squared. This is going to be 18 units squared. And this bottom one is going to be 18 units squared. So what's left is to calculate the area of this square that's left over in the middle. Okay, that square there I've highlighted in green. The length, the side edge of that square is really just going to be the difference between the long edge of the right triangle, which is 9, and the short edge of the right triangle, which is 4. So this is going to be, if I just counted 1, 2, 3, 4, 5, it's 9 minus 4, or 5. So this area inside is going to be 25 units squared. And this one's easy because we can actually count all 25 squares here. So when we talk about the total area, so the total area is going to work out to 4 times 18 plus the 25 square in the middle. So this works out to be 4 times 18 is 72 plus 25, and that's going to give us 97 units squared. So there's 97 squares inside this non-perfect square. And if we try to square root that, we can see that that does not give us a perfect square root. Okay, so this is a non-perfect square. Okay, so it's a square shape, but it's not a perfect square number of area. So the side length here is not going to be a whole number side length. So we can do the same thing here. We want to, first of all, break this up into this right triangles and the square in the middle. So I'm going to start by drawing my line straight down. Okay, and from each vertex I can draw straight down and straight across. And we want to follow the grid lines because the grid lines are the vertical and horizontal grid lines will allow us to break this up into nice right triangles and squares. So there we have it. So we have our right triangles then. So again, we don't go across the grid lines. We go straight down, up and down, and straight left and right. So I have my right triangle at the top here. I'm going to count it across. It's going to be 3 high, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 across. Okay, and so the area inside here is going to be 3 times 12 divided by 2, and that's going to be 18 units squared. And since these are all symmetrical, these are all going to be 18 units squared. And then we're left with the square in the middle. So the square in the middle, which I'll highlight in green, is, and we can count across, and we can see that that's going to be a 9 by 9 square. And again, notice that that length of this square edge is really just going to be the long edge 12 minus the short edge of 3. Okay, so it's like going to be the long minus the short. In this case, it's going to be 9 times 9, or 81 units squared. So working out the total area then, okay, the total area of this square is going to be 4 times 18. So there's 4 right triangles here. And we're going to add the 81 squares in the middle. So we end up with 72 plus 81. And that's going to give us an area of 153 units squared. And again, this is, since we have 153 units squared, we know this is a non-perfect square because the 153 is not a square number. And that means that these edge lengths, the side length of the square, the black side lengths, are not whole number values. Okay, these are not whole number values, and these are not perfect square lengths.